Tonight, look up at the moon. Now imagine it's gone, not covered by clouds, not in a lunar eclipse, gone, permanently, vanished from the sky like it never existed. Most people think losing the moon means darker nights. Maybe some wolves stop howling. Life goes on. They are catastrophically wrong. The moon is not a light. It is not decoration. It is the single most important stabilizing force acting on this planet right now. And without it, Earth would become a different world entirely. Your tides, your seasons, your climate, your axial stability, all of it, regulated, controlled, and kept predictable by that one rock orbiting 239,000 miles above your head. And the timeline of what happens after it disappears will genuinely disturb you. And by the end of this video, you'll never look at the moon the same way again. Let's start with what most people think the moon actually does. Most people know the moon controls ocean tides. Pull the moon away, tides get weaker. Fair enough. Some people know the moon affects animal behavior, migration patterns, breeding cycles, nocturnal hunting, and almost everyone has heard that ancient humans used the moon as a calendar. That's the common understanding. And none of it is wrong. But here's the crack in that knowledge. Every single one of those effects, tides, animal behavior, calendars, they're surface-level consequences of something far more fundamental that the moon is doing for Earth every single time of every single day. The moon is stabilizing the angle at which Earth tilts toward the sun. Right now, Earth sits at a 23.5-degree axial tilt. That tilt is what gives you seasons. Summer, when your hemisphere leans toward the sun. Winter, when it leans away. Predictable, consistent, stable for millions of years. Without the moon's gravitational influence, that tilt doesn't stay at 23.5 degrees. It wanders, dramatically. Scientists calculate it could swing anywhere between 0 and 85 degrees over millions of years, completely at random, driven by the gravitational tugs of Jupiter and the other planets. At 0 degrees tilt, no seasons at all. Equator permanently scorched. Poles permanently frozen. At 85 degrees, Earth lying almost on its side, with one pole facing the sun for months, then the other. Seasons that would make current weather look completely tame. Here are the 3 questions we're answering today. What exactly happens in the first hours, days, and years after the moon disappears? What does the science say about Earth's long-term stability without it? And why is the moon's existence not an accident, but one of the most important lucky breaks in Earth's entire history? So let's go deeper than anyone has ever taken you before. Let's run the clock. Moon disappears. Right now. What actually happens? Within the first hour, nothing dramatic that you'd notice standing on a beach. The ocean isn't going to instantly go flat. The gravitational effect of the moon on Earth, tides, operates on a cycle, and that cycle needs time to unwind. But within 6 hours, the next tide cycle, something is obviously wrong. Tides that normally rise and fall by 10, 15, even 30 feet in places like the Bay of Fundy in Canada, those tides collapse to a fraction of their normal height. Only solar tides remain, the much weaker tidal pull of the sun alone. This is catastrophic for coastal ecosystems. Tidal zones, those bands of coastline that are underwater at high tide and exposed at low tide, are some of the most biologically productive environments on Earth. Barnacles, mussels, crabs, countless fish species, shorebirds, their entire life cycles are synchronized to tidal rhythms that have existed for billions of years. Remove those rhythms, and the disruption cascades through the food web almost immediately. Within 24 hours, coastal communities worldwide are watching the ocean behave in ways it never has in recorded human history. Here's where it gets genuinely strange. The moon doesn't just affect tides. It's been slowing Earth's rotation for billions of years through tidal friction, the drag that ocean tides create against Earth's seafloor as they're pulled by the moon. Without that braking force, Earth's rotation slowly begins to speed up over geological time. Days get shorter. Eventually, over millions of years, Earth could rotate significantly faster. Some models suggest days could eventually shorten to somewhere around 6 to 8 hours. A faster rotating Earth isn't just a curiosity. It has massive atmospheric consequences. Faster rotation drives stronger Coriolis forces, the physics that determine how winds and weather systems spin. Hurricanes, jet streams, weather patterns, all of them would intensify and change character in a faster rotating world. Did you know? When Earth first formed 4.5 billion years ago, before the Moon existed, a day on Earth was only about 6 hours long. The Moon has been slowing us down ever since. Without it, we'd gradually drift back toward that ancient, faster, more chaotic rotation. But here's the part that nobody talks about. The loss of the Moon doesn't just change our days and our tides. Over millions of years, it would make Earth's entire climate system essentially unpredictable in ways that make current climate change look minor by comparison. This is the big one, the thing that would ultimately make Earth unrecognizable. Mars has no large moon. Mars's axial tilt has wandered between about 10 and 60 degrees over its history, chaotically, driven by planetary gravitational interactions with no stabilizing moon to hold it steady. The result? Mars has experienced climate swings so extreme that its poles were once near the equator, seasons that would be unimaginable by Earth standards. Earth, with its 23.5-degree tilt locked in place by the Moon's gravity, has enjoyed stable, predictable seasons for hundreds of millions of years. That stability is one of the primary reasons complex life evolved here and not somewhere else. Remove the Moon, and over millions of years, Earth becomes Mars. Climatically chaotic, seasonally unpredictable, far less hospitable to the kind of stable, long-term evolution that produced every species alive today, including you. Coming up, what scientists and engineers have discovered about just how razor-thin the margin was for the Moon to exist at all, and why its formation was one of the most improbable events in the cosmos. 2 Fees. In school, you probably learned that the Moon formed when a Mars-sized object called Theia crashed into early Earth about 4.5 billion years ago. The debris from that collision coalesced in orbit and became the Moon. Simple, clean, done. What textbooks don't emphasize is just how precisely calibrated that collision had to be to produce a Moon that actually does what ours does. If Theia had been slightly smaller, the Moon would be too small to stabilize Earth's axial tilt. If it had been slightly larger, the collision might have destroyed Earth entirely, or produced a Moon so massive it would have spiraled back into Earth due to excessive gravitational interaction. If the collision had happened at a slightly different angle, the debris field would have been wrong, producing no stable Moon at all. Planetary scientists who study the conditions of the early solar system describe the Theia impact as being within an extraordinarily narrow range of parameters that produced exactly the right Moon for exactly the right planet. Too big, too small, wrong angle, wrong timing, any of those, and you don't get a Moon that stabilizes a habitable planet. You get Mars. Wait, it gets even more interesting. The Cambrian explosion, the period roughly 540 million years ago, when complex animal life, suddenly diversified at an extraordinary rate, happened during a period of remarkable, long-term climate stability on Earth. Paleoclimatologists who study that era point to Earth's stable axial tilt as one of the key enabling conditions for the Cambrian explosion. Predictable seasons meant predictable food sources. Predictable food sources meant evolutionary pressure toward complexity rather than just survival. The Moon didn't just keep Earth stable, it may have directly enabled the conditions that led to every complex animal on Earth today, including every human being who has ever lived. Here is the most shocking fact in this entire video. The chain of events that produced you, a Theia impact at precisely the right size and angle, producing precisely the right Moon, stabilizing precisely the right tilt, enabling 500 million years of complex life evolution, that entire chain was not inevitable. It was improbable, and the Moon is the hinge point on which all of it balanced. You've probably walked on a beach and noticed the tide line, that band of wet sand seaweed, and shells marking where the high tide reached. That line represents one of the most productive biological zones on Earth. Everything from the crabs you see at low tide to the fish that feed in tidal shallows to the shorebirds that feed on both. All of it depends on that predictable rhythm of water rising and falling twice a day. Without the moon, the tidal zone as Americans experience it on both the Atlantic and Pacific coasts would be dramatically reduced. Beach ecosystems from Maine to California, from Florida to Oregon, fundamentally altered. Fishing industries dependent on tidal species, disrupted. Coastal infrastructure designed around tidal ranges, suddenly operating in conditions it was never designed for. The moon's role in Earth's habitability has fundamentally changed how astronomers search for life beyond Earth. When NASA and ESA now evaluate exoplanets as candidates for life, the presence of a large stabilizing moon is increasingly factored into habitability models. A planet the right distance from its star, in the so-called habitable zone, may still be climatically chaotic without a large moon to stabilize its axial tilt. This is one reason planetary scientists now believe that truly stable, long-term habitable planets may be rarer than the simple habitable zone calculation suggests. Our moon isn't just a bonus, it may be a prerequisite. The moon's stabilizing effect on Earth's axial tilt works exactly like a gyroscope. A spinning gyroscope resists being knocked off its axis. The faster it spins, the more stable it is. The moon's gravitational pull acts like a gyroscopic stabilizer on Earth, resisting the chaotic tugs of Jupiter and the other planets that would otherwise send Earth's tilt wandering. Remove the gyroscope, and the wobble begins. Slowly at first, then catastrophically over millions of years. And this is just the beginning of how deep this goes. Now here's something that most people never connect to this topic. The moon is already leaving. Every single year, the moon moves approximately 3.8 centimeters further away from Earth. That's about the rate at which your fingernails grow. It doesn't sound like much, but it adds up. When the moon first formed 4.5 billion years ago, it was roughly 15 times closer to Earth than it is today. The tides it generated were hundreds of times more powerful. The sky would have appeared enormous, a moon that filled a huge portion of the night sky, and it's been drifting outward ever since. Slowly, steadily, inevitably, in roughly 600 million years, the moon will have drifted far enough away that total solar eclipses will no longer be possible. The moon will appear too small in the sky to completely cover the sun. Think of the Earth-Moon system like a spinning top, and the hand that keeps it balanced. Right now, that hand, the moon, is perfectly positioned, keeping us stable, keeping our seasons predictable, keeping complex life possible. But the hand is slowly pulling away, and in astronomical time, it was only ever going to be there for a while. We are living in the window, so here's what we uncovered today. Without the moon, Earth's tides collapse within hours, devastating coastal ecosystems that billions of species depend on, while Earth's rotation slowly accelerates back toward the chaotic 6-hour days of the primordial planet. Over millions of years, Earth's axial tilt would wander like Mars, swinging between extremes that make current climate change look trivial, destroying the seasonal stability that enabled 500 million years of complex life evolution. And the Theia impact that created the moon was so precisely calibrated that planetary scientists describe it as one of the most improbable lucky breaks in the history of the solar system, the single event that made everything else possible. The moon isn't decoration. It is the reason Earth has been stable enough, long enough, for intelligence to evolve and look back up at it and wonder what would happen if it disappeared. Now I want to know, did you know the moon was drifting away? And what do you think would be the first thing your being personally notice if the moon disappeared tomorrow? Drop it in the comments. I read every single one. In our next video, we're going somewhere even stranger. We're going to find out why the James Webb Space Telescope just spotted something in deep space that breaks one of the most fundamental assumptions cosmologists have made about how the universe works, and the answer might change everything. The world is not what it looks like on the surface. It never was. This is Logivra, And the logic was always there. You just needed someone to show you where to look.